So this is experiment number 4. Okay, we'll deal with single phase transformer, and what we're going to do, we're finding the equivalent circuit and performance indicators. So actually all of these are just covered in the lecture class, so you should have a very fresh idea about it. You should have, if you have followed me in the lecture class, you should have a very fresh idea of what they are. So two things actually we are going to do. One is we'll find the equivalent circuit, number one, and we know that equivalent circuit is only made for the case of practical transformer, right?
Yeah.
And the practical transformer we can represent by a circuit which looks like this. I hope you can remember. Okay, a parallel branch and a series branch.
Yes.
So parallel branch has two
RC.
pairs, RC,
XM.
XM, and this R equivalent and this is X equivalent. Okay, so this side is our primary side, VP, IP is flowing over here, and this is our VS, and IS is flowing over here. Okay, now all of them are actually representing something, because inside this R equivalent we have R primary, R secondary, which are representing the copper loss. Yes. Right? Now this X equivalent is representing actually the leakage loss, and XM is representing the magnetization loss, and RC is representing the core loss, which is having two pairs, hysteresis and the eddy current loss. Okay, so all of them actually representing something. Now our first task, which is to find the equivalent circuit parameter, we need to find the value of these four: RC, XM, R equivalent, X equivalent. Clear? We know that, like, we have to find the values. Yes.
What about R equivalent?
R equivalent is RP plus RS, that will primary resistor, secondary resistor. So
What's the loss?
this is the copper loss. Yes, copper loss. Okay. Now, if you can remember how we get their values. To get their values, we do two tests actually.
Short circuit, open circuit.
Exactly. So this RC and XM we find by open circuit test, and this R equivalent and X equivalent we find through short circuit test. Okay. Now very quickly let me remind you what we did inside the open circuit test. In the open circuit test, we keep the secondary open. Like, this is the secondary side. We keep this open. Okay, ask me if you don't understand anything. And in the primary side we apply V rated voltage. So in the lab we will apply actually 230 volt. Okay, 230 volt. And what we will do, from the primary side we will calculate voltage open circuit, current open circuit, and power open circuit. Are you with me? So that means, we will connect through the casilab, and the casilab will give us a voltage and a current, and the power is the multiplication of voltage, current, and power factor, isn't it? So that means from the primary side we will get voltage open circuit, current open circuit, and power open circuit, and from here we will calculate RC and XM. Is it clear?
Yes.
So this is what we do in the open circuit test. So this is the open circuit test. Okay. For the short circuit test, what we do, for example, this is our transformer. We keep the secondary side shorted. Okay. We keep the secondary side shorted in the short circuit. So this is our secondary side and this is our primary side. Now what we do, we apply a voltage in the primary side
7 to 9.
so that it can be any value. It can be any value, but what we look at the secondary current, and we make sure that the current flowing is I rated. What is the current flowing in the secondary? I rated. That means rated current. Now for our case, like, if you look carefully, whenever you will come to the table, you will see in the secondary side the I rated here written 1.36. You understand? So in the input side, you will apply a voltage slowly, in a way that the secondary current will reach 1.36. Why slowly? Why you have to be careful?
You don't want to ruin the
Because the secondary side is short. If you apply suddenly a big value, it will simply burn the coil. trip the circuit breaker, burn the fuse, or whatever will happen, it may happen. So this I rated, you need to make sure that this is 1.36 ampere. Okay, to reach that value, usually in our lab we get that value at 6 to 10 volt, or sometimes 11 volt, sometimes 9 volt, it depends. Okay, so that you can see the difference. Very small voltage we apply for short circuit test, but the current is very high.
Yes.
And here in the open circuit test we apply a high voltage, but the current is almost zero. It is zero actually, because this is open circuit. Okay, so this is what we do. So from here what we get voltage short circuit, current short circuit, power short circuit.
And the count.
Yes, so from here we calculate R equivalent and X equivalent. Okay, now how you calculate like this R? So this calculate you will calculate by formula actually. Okay, so in the lab manual, first page, so if you open the lab manual, in the first page all these formulas are given to you, second page in fact. So if you look carefully, equation number 1 to 4 will give you RC and XM. Equation number 5, 6, 7 will give you R equivalent and X equivalent. Okay, so these equations you have to use while writing the report. Okay, not in the lab, because I will give you, or we will take only these values: short circuit, this voltage, current and power, this voltage, current and power. We will take them and we'll leave. You understand? Later you will do the calculation using the calculator. You will find or calculate the R equivalent, X equivalent, and so on. Okay, so this is the open circuit test and short circuit test. So one thing I have missed is that over here, to see how much current is flowing in the secondary, you need to put an extra ammeter. You understand? You need to put an extra ammeter so that you can see that yes, how much is the value, and you need to be careful that it is not crossing 1.36. Okay, so this can be a question, why we use an extra ammeter at the time of short circuit test.
Because the current is high. We need to check.
Yes, you need to see carefully that whether it is crossing the rated value or not. Clear, guys? Okay, so this is actually the open circuit test and short circuit test and the equivalent circuit parameter calculation. So do you have any question from the first part? Equivalent circuit? No. Second part is performance indicator. Okay, so how many performance indicators we have for the transformer? We just covered in the lecture class. Performance indicators. 2 actually, right? Can you remember? Only 2 performance indicators. One is what? No. Efficiency is one of them. And?
The voltage regulation.
Exactly. Yes. Number 1 is efficiency. And number 2 is voltage regulation. Okay, voltage regulation. So now you have to understand that if you want to find efficiency or voltage regulation, can you find them using these tests, open circuit test, short circuit test and something? You can never, right? Why? Because to calculate both of them you need secondary side power or secondary side voltage or something like that, right? But here in one of the cases the secondary is open, so current is 0. In another side it is short, that means voltage is 0. So that means you cannot find efficiency and voltage regulation using open circuit test and short circuit test. So what test you will do? You will do another test which is known as load test, the normal one, load test. In the lab manual they call it load test. What is load test? It's very normal that you have a normal primary side, a primary side and a secondary side, and in the secondary side you have a load. You understand? In the secondary side what you have? A normal load. Can you guess which load we will use? Resistance, right? So we have a resistive load. You can see from the symbol that is the variable. Okay, so we'll use the variable resistor we have. Okay, so this variable resistor we'll use in the secondary side. Now what we'll do? We will apply a voltage here and we will measure V primary, that means V1, I primary, that means I1, and power factor primary, which is power factor 1. So VI into power factor will give us what? P1, right?
Yes.
Are you with me?
Yes.
This P1 is what actually? P input, right?
Yeah.
Isn't it? Because this is in the input side. Now the same thing we'll do in the output side. Okay, it's very simple. You put a voltmeter, you measure V2. You put an ammeter, you measure I2, and you measure power factor 2. So from there you calculate P2, right?
Yeah.
Who is this P2?
Second is
Yeah, this is P out, right?
Yeah.
So now you know what is efficiency. Equals to P out divided by P in. Multiply with 100. Okay, it's percentage. Whatever. I don't have space to write. So you can see, like it's very easy, but you have to do it. That means, you have to connect the load. You have to, define the Cassie lab parameter so that it gives you V1, I1, P in, and V2, I2, and P out. And then you have to write the formula efficiency. And you will see that the efficiency will get a good value, 90%. Over 90% usually we get. As I said, that the efficiency for transformer is very high because there is no rotating machine, a static device. Okay? So this is what we will do for the efficiency. Clear?
Yes.
Any question, guys? Efficiency, you understand? Now in the exam, I will, some part of the exam will be viva, interview. You understand? And I will ask you this type of questions that, if you want to find out the efficiency of the single phase transformer, how you will do it in the lab. You understand? You have to tell this. I will connect a load in the secondary, then I will apply a voltage, I will measure this, I will measure this, and this formula we will use to find. For example, I will ask you that how can you find out the value of RC and XM in the lab? Okay? Then you have to explain me, doctor, I have to do the open circuit test. And this is how we do the open circuit test. And we calculate the value of this voltage, current and power. And from there, this formula to get RC and XM. Okay? So whatever I am explaining over here, this is the main syllabus for your exam. Remember, the main syllabus for your exam is whatever I am delivering from here, standing from here. First half hour of the lab. This is the most important because everything we do in the lab, I explain standing here first, very elaborately. I tell you to ask me question if there is anything wrong or whatever. Okay, so this is the main part of your syllabus for the exam or whatever you think. Okay, so make sure that what I explain over here is clear to you. Okay, if it is not clear, please make sure you ask me. So the next one is voltage regulation. What is the formula? Can you remember? Voltage no load minus voltage load or full load divided by voltage load, and in 100%. Okay, so this voltage no load, can you tell me who it is? I have already found this one.
في input.
No. The open
This voltage no load is actually this VOC. You understand this? Do you understand this thing, guys?
Yeah.
Because this V open circuit means what? There is no load, right?
Yeah. Yes.
So this voltage open circuit is actually this voltage no load, right? Isn't it?
Yes.
So can you tell me what is the value?
0.
Voltage open circuit is 0.
V8.
Yes, we rated. I'm saying it. We are taking it from the primary side. How much voltage we applied in the primary side? We rated, which is 230 volt, right? Are you with me?
Yes.
Because all these values we take from the primary side, right? And the primary side we apply 230 volt. So voltage open circuit is 230 volt. So that means voltage no load is 230 volt, right? Is it clear?
Yeah.
Okay. Now who is this VL? Yeah, where it is? Who it is in the board?
No voltage.
It's 6 to 10.
It's 6 to 10.
Doctor, this one.
This is V2. Hello, come on. Why can't you relate? I don't know. This is this V2. V2 is your V load, right? V2 is where? V2 is here, right? So that means your secondary side voltage. And this secondary side you have a load. Isn't it?
Yeah.
So as because you have a load, this is your load voltage. It's written VL, load voltage. Now you're saying 6 to 10 volt. 6 to 10 volt, is this the load voltage? It's never a load voltage, right? And here you are making it short circuit, so it's not the load voltage. So the load voltage is this one, which is V2, right? So remember, like I'm writing it over here, I will ask these questions somewhere. I'm repeating these things again and again, either in the lab exam or in the lecture exam. You will be asked, these questions for sure. Okay, make sure that you understand these things. So this V no load actually V open circuit, and this VL is actually your V2. Okay, now I hope everything is clear. Now you can understand that in the chapter of transformer, whatever we covered in last whole week, almost 50-60 slides are all summarized here in this lab, isn't it? You can see, like, even though the lab will be small, but it is a summary of the whole, a big part of the chapter number 4, chapter 3 of our lecture class. So the equivalent circuit and the performance indicators. Inside the performance indicators, we have the efficiency and the voltage regulation. Clear? Do you have any questions, guys? No. Thank you. So we'll go to, we have given the connection for the open circuit test. Okay, so this is the open circuit test. This is our transformer, and the source is here. It's a single phase AC source, and we are measuring actually one current and two voltages. The first current is the primary current, because we know that we need a primary current, the current in the primary side, and the voltage, the primary voltage. And also we are measuring a secondary voltage, which is here. You can see, like, this is the secondary side of the transformer, which is directly connected over here. So that means we are measuring secondary voltage. Okay, I will tell you later that why we need secondary voltage here. Okay, and also here we have done all the Castle up setups. Now in today's experiment, we will not show you in detail. You have done by yourself. Okay, like how to do that and everything. Now what we'll do? We'll do the test, right? So to do the test, what you need to do, just apply the rated voltage in the primary side, isn't it? Like as I explained in the table, remember? Yeah. Like we will apply the rated voltage in the primary side. What is the rated voltage? How much?
230.
230. Yeah. How you know? You know from here, right? Yeah. It is written 230 over here. Yes. So you can easily understand that this is our rated voltage, 230 in the primary, because this is the primary side. Okay? Now we will turn this one on. Okay, and we will apply the 230 volt here. So can you see what is our primary voltage? Primary voltage is V1. Secondary voltage V2. This is power and current. So everything will happen here. You will see the values live. You understand? Yeah. So you see, I am applying the voltage. Sorry, it's not. No, not put in the right position. Yes. It will work now.
You take one phase?
It doesn't work.
Why?
Now we will apply the 230 volt, right? So you see, like V1. So we are applying the voltage. So which is 230 volts. Okay? So the maximum voltage we applied, but it cannot reach 230. You can see the maximum it can give is 221 or something. This is the maximum it can give, because it has become old. So this is the maximum it can give. So this is the value for V1, primary voltage, secondary voltage, primary current, secondary current. So you have to take this data and put down the numbers over here. Okay? Now I told you that, yes. What is the benefit? We use the benefit for the protection, but because it was broken, I have connected directly. I took a risk, but it's fine. So now what we'll do, listen carefully, to calculate the RC and XM, RC and XM, we need this one, V1, we need P0, we need I0, right? Mm-hmm. But here we are calculating V2 also. Why? To check that, we know that A equals to N1 by N2 and also V1 by V2, isn't it?
Yes.
Okay, so N1 by N2 you can find from here. You can see N1 equals to 847. So you see here you write 847 is N1 and the secondary is 456. So 456 56. So N1 by N2, you check what is the value of A. Okay?
From cassette.
No, using your calculator.
Yeah.
Okay? Now you check whether this is same to V1 by V2. So that means V1 is how much here? 220, right?
Yes.
And V2 equals to how much? 116.4. Okay? So use your calculator and see. So the value is actually 1.85 here. We calculated 1.85. Okay? Now if you do this one, can you check? 220 divided by 116.4.
So it gets
1.89. 1.89. So you see, like the thing we learned in the lecture class, V1 by V2 equals to N1 by N2. We have seen it, from a practical live data, right? Like the V1 by V2 is matching with whatever we are having, the number of turns in the primary, secondary as well. Clear? Clear as everyone? Okay. So now we'll switch it off, and then we will do the short circuit test. Okay. Experiment is doing the short circuit test. So you know how to do that, right? We do the secondary side short.
Yeah.
And we take the data, voltage, current and power from the primary side. But you have to see the current in the secondary side also, so that you can see that whether the rated current is flowing or not. Okay? What is the rated current in the secondary? What is the rated current in the secondary? 1.36, right? So you have to be careful that the voltage we apply in the primary, so that the secondary current does not exceed this value. Okay? Because this is the maximum value the transformer can handle. Okay? So now we turn on, like we have defined everything. Yes. Now before we were measuring one voltage, one current and two voltage. Now in the open circuit test, in the short circuit test we are measuring, you see, one voltage and two currents. Why? Because now we need primary current and secondary current both. So we are turning on this. Make sure this is 0.
Yes.
Turning on this, and we have to apply the voltage very slowly. Okay? So that, look carefully. So that, and we have to look here at this value. This should be 1.36. So I am applying the voltage. You see, it is increasing very quick.
Yes.
Okay? So I have to stop before reaching 1 point. It's very fast actually. You cannot pick the correct value. So you see, this is 1.33.
Yeah.
You understand? So that means this less than 1.36, right? And so how much voltage is giving this number of currents? So you see, 8 volt only. Remember, I said that from 6 to 10 volt, you will reach the saturation. So it is only 8 volt. Okay? This is our power, this is your current. This current is the primary or secondary? This current is primary. This is your secondary, right? So now you have to take the data. You see over here, voltage short circuit is how much? 8 volt. I short circuit is how much? 0.70. Okay? I2, like it is actually your I short circuit. This is 1.34. Okay?
Yes.
And the power short circuit is how much? 5.63, or this what? Now who is this A? Is the turn ratio, right?
Yeah.
Now can you remember A equals to what? N1 by N2, V1 by V2. Here we will use I2 divided by I1.
Yeah.
So I2 is how much? 1.34, and this is I2, and I1 equals to, this is actually I1. It should be I1 actually, or I short circuit. This is not the short circuit. This is I rated. So this I1 equals to 0.7. 0.7. Tell me the value. 1.34, 0.7. 1.91. So 1.91. Okay? So maybe you can remember that it's not here. In another book I calculated that V1 by V2 and N1 by N2, it was around 1.85 or something like that, right? So that means, whatever formula you use, you get the turn ratio equals to same, they're same to each other. So this is the short circuit test, okay? So these values you will use to calculate the value of R equivalent and X equivalent. Clear? And which formulas you have to use? These formulas. Many things are written over here. So you can see formula number 5, 6 and 7 will give you R equivalent and X equivalent.
Yeah.
And formula 1 to 4 will give you RC and XM.
Yes.
Clear? So done. So we'll switch it. Yes. So they are actually from the primary side. So if you look carefully, if you see where the wires are going and so on, okay, there are lots of wires. It's difficult to find, but if you look very carefully, you'll notice that these first two are actually coming from somehow from the primary side, and the second two, like the current and voltage, they're coming from the secondary side. Clear?
Yes.
Then we will select here, there in the CASI lab there is the option to select cos theta 1 and cos theta 2. You need to select that one. So that will give you, power factor 1, power factor 2. Okay. Then what you have to do? You have to write the formula P in equals to V1 I1 cos theta 1, right? So can you see here, guys? Just have a look. You see I've written all the formulas here. So you see this is P in. Can you notice P in? So this is P in equals to V1 I1 cos theta 1. Okay. Similarly, this is P out. Okay. P out equals to V2 I2 cos theta 2, right?
Yes.
Then I have defined the efficiency. Efficiency equals to P out divided by P in multiplied with 100. Okay. Maybe it is not very clear because you are seeing from far. But whenever I will leave from here, you should come and check one by one all the formulas are correct or not. And then I have written the formula for voltage regulation. I explained over there also that in the voltage regulation, your voltage no load equals to your open circuit voltage. Remember?
Yes.
So we applied around 217, 218. Remember?
Yes.
We planned to apply 230, but we could reach around 220. So that's why I have written here directly 217 or 220, whatever. Okay. And who is the V load? V load equals to V2, right? So I have written here V2 as well. So everything is ready. Now we'll just take the data. How to take the data? We'll apply the voltage, and then for different percentage of resistance, we'll press F9. And that will give us, you can see like here I have brought P in, V1, I1, V2, I2, P out, efficiency and voltage regulation. So whenever I will press F9, it will give you all the data, automatically without doing any further calculation. It will give you directly. Okay. So before taking the data, do you have any question? Any part not clear? Okay, great. So it's on everything. Let me double check that the voltage we apply, is the maximum voltage. So I turn on the voltage source. Okay. For the safety, we bring the current and the voltage in front of your eyes, so that if anything is wrong, we can see it immediately. You understand?
Yes.
I bring the voltage and the current of the secondary and the primary side in front of our eyes, so that if there is anything abnormal, I can see it. Okay. Now I apply the voltage and the primary voltage. This is live value. That means whatever I am applying here, you're seeing exactly that value here. Okay. So you see the V1 needs to be 230, isn't it? Yeah. Okay. So the maximum we are reaching is 216. So the secondary, as because this is a step down, this is 113 and so on. Okay. Now, this is now connected, the load is now connected with the source, with all the things you need. Now just F9 will give you all the data. So it will appear over here. So you see F9 is how much? Oh, so you can see the values. Efficiency is 95% almost. Okay. Voltage regulation is also giving very high value, which is not good, but well, we're getting it. So 90% F9, and then 80 or 70%. So here it is said to take some data, maybe 6-7 data you can take. Okay, F9, and then 50% F9, 40% F9, and 20% you can take F9. Okay, so you can see what we are doing. We are reducing actually the what we're doing, we're reducing the load, right?
Yes.
So that means secondary current is increasing, right? Isn't it? The current should increase. Can you see how much current we have reached? 1.4 already. You understand?
Yeah.
Which is, you know,
It's overwhelming.
it's over actually, but you know, it's saying to stop 1.36, but it can reach up to 1.4, 1.5. Okay? So can you see? 1.4 is the value we're getting here. So we must have to stop now. Otherwise, you know, it may burn our machine. So, you know, we are going back. We're going back. And we are making it 0 volt. So you can look carefully your values, you know, like the V in is not changed. The whole values were around 217 because we didn't change any value of the voltage, right? But we changed actually what? The resistance in the secondary side, right? So as we changed the resistance of the secondary side, it had an impact on the current. Okay, so you can see like the I2 was changing. Can you tell me whether the V2 will change or not? V2?
Vito?
Change? He said change. Will V2 change? V2 will not change because we decreased the resistance, current increased, right?
Yeah.
V multiply I is constant, isn't it? You know, because you know, if you decrease the resistance, current will increase, but multiplication will remain the same. V equals to IR, isn't it? So you can see like the V1 and V2, they remain same. You know, there is a little fluctuation over there, but you know, most of the thing, the current has been changed, and you can see the power and so on. So look at the efficiencies. You know, they vary between 94 and 96%. Okay, which is a very good efficiency for the transformer.
How much?
94%, 95, 96%. So clear, guys? Any question?
Clear.
Okay. Thank you.